Hello everyone, welcome to the second chapter of Snowflake. In the previous video, we have seen about what is Snowflake? Why should we go for Snowflake? Getting started with Snowflake. And about Snowflake additions. In this video, we will see about Snowflake architecture. Snowflake have three-layered architecture. The Cloud Services layer. This layer is responsible for coordinating activities across Snowflake. The Query Processing layer. This contains the virtual warehouse which provides the necessary compute power to process the queries. The Database Storage layer. As the name implies, this layer contains the necessary storage to store data. All these layers are loosely coupled, which makes each layer act independent. First, let us see about the Cloud Services layer. As previously said, the Cloud Services layer is a collection of services that coordinate activities across Snowflake. These services tie together all of the different components of Snowflake in order to process user requests, from login to query dispatch. And these services also run on compute instances provisioned by Snowflake from the cloud provider. The Cloud Services layer is responsible for the following activities across Snowflake: authentication, infrastructure management, metadata management, query parsing and optimization, and access control. Next, the Query Processing layer. The Query Processing layer contains the virtual warehouse which provides the necessary compute power to process the queries. Now let us see in detail what is virtual warehouse. The virtual warehouse or warehouse is simply a cluster of compute resources. It provides the required resources, such as CPU, memory, and temporary storage to retrieve rows from tables and views, and updating rows, loading and unloading data from tables. Users can select the warehouse size based on their requirement from extra small to 6x large. Snowflake also provides Snowpark optimized warehouses which provide 16 times more memory per node compared to a standard Snowflake virtual warehouse. These types of warehouses are used for the queries which require large memory, such as machine learning training. Another unique feature from virtual warehouses is that it can be a multi-cluster warehouse. The users can add additional compute clusters of the same warehouse size to the existing warehouse. Instead of increasing or decreasing the warehouse size, compute clusters can be added or removed within the warehouse. This enables scaling within the warehouse, which is useful in conserving credits. A warehouse can have a minimum of 1 cluster and maximum of 10 clusters. If minimum cluster is equal to maximum cluster, we can say it as the warehouse is in maximized mode. And if minimum cluster is not equal to maximum cluster, we can say it as the warehouse is in autoscale mode. And the users can select between two scaling options. Standard, which minimizes queuing by starting additional clusters over conserving credits. Economy, which favors conserving credits than queuing. Coming to the billing of virtual warehouse. The credits are consumed based on the warehouse size, number of clusters, and number of warehouses, and length of time each warehouse running. Warehouse utilizes per second billing with the minimum 60 seconds billed for a warehouse when provisioned and every time it restarted. And finally, the database storage layer. When data is loaded into Snowflake, Snowflake reorganizes that data into its internal optimized, compressed, columnar format. All data in Snowflake is stored physically in the form of micropartitions. Micropartitions are nothing but contiguous units of storage. When data is loaded into the table, Snowflake automatically stores the data in micropartitions. Let's consider the first row. Here the columns are stored independently within micropartitions and a row of data is stored in the same micropartition. Similarly, the upcoming rows are stored in the same fashion. As the name suggests, micropartitions are small in size. When the limit exceeds, a new micropartition is created and the next rows are stored in the similar way. Micropartitions are immutable. Every time when the table is updated, the new value is added at the end and mapped accordingly. Micropartitioning is automatically performed on all Snowflake tables. Each micropartition contains between 50 megabytes and 500 megabytes of uncompressed data. In this video we have seen about the three layers in Snowflake architecture. That is, Cloud Services layer, Query Processing layer, and Database Storage layer. We will back with more interesting topics in the upcoming videos. Thanks for watching. Subscribe to our channel for more interesting videos.